Shalom. In this video, I want to do a problem on compound interest, just to make sure you could handle that properly. Also, it is in line with exponential functions. It's a real life application of it, and compound interest is what you're going to use with banking. Okay, it helps you to determine what's the best deal in the banking. What rate would you take, and depending on how they compound their interest. So let's look at a problem here. So first of all, let's write out the formula, and that formula will be the guide. So the formula is A, where A is the final amount you get and P is the principal, and then you multiply it by 1 plus the rate divided by n, and then to the power n times t. Okay, then final amount, initial amount. If you notice, this whole parenthesis replaces e in the exponential function. So this is your kind of either the growth. If it is growth, is plus. If it is decay, is minus. So or decrease. Okay, but when you're compounding interest is always increase. So that's why this remains for that. So n is how many times this amount is compounded. How many times is it compounded in a year? In 1 year, how many times it is compounded? Then t is the year, as we have it in the other one. So n is one of the things that is a different here. So let's interpret it in a problem. So finding our n, sometimes that's what's confusing to people. So if we look at this one, okay, number A, it says that this is compounded annually. It is compounded annually, so it's once a year. So your n is going to be 1. Okay, this is compounded monthly. If it's compounded monthly means every month. So how many months are there in a year? 12. So your n is going to be 12. Okay, this one, it's compounded quarterly. Quarter means 4. Okay, quarter means 4. So 4 times a year. So your n is going to be 4. And so forth. Okay, so let's look at, I was just going through this problem. It looks like this E is actually looks like the one that will be a little tricky. Okay, so let's do that one. Okay, I'm sure once we do it, you should be able to handle everything else. So let's write out everything we need. An investor has 12,500. So that will be our P, the initial amount it starts with. So your P is 12,500. Okay, I'm going to move this after. So that. And then we are looking for annual percent interest. So we are looking for the percent interest. It is compounded quarterly. So our n, we already got out, is 4. Okay. Our n is 4. So what time percent of interest is going to use to require to double this in 15 years. So the time is 15, and then the doubling, so our A is going to be doubling the principal. So this is the principal. So the A is going to be whatever the principal is times 2. We double it. So that's going to give us 12,500 times 2. Okay, so that's 25,000. So this is 25,000. Okay, so we have all we need. Then we plug things into our formula. So again, let me rewrite it down here. A equals P times 1 plus R over N T. Okay, so we have A, so which we found. So that's 25. So that's 25,000. We have our P2, which is 12,500. And then 1 plus R over N Oh, our n is 4, right? It's 4, so we put that, we have it. R is what we don't have, so we leave it like that. N is 4, and 4 times t, our t is 15. Okay, so here we have all put in the formula. So we'll go ahead and multiply that exponent 4 times 15. So that's 60. Okay, so that becomes, we can go ahead and divide this by 12,500 also. Okay, 0 can cross, this can cross out, and this can cross out. So we have 250 divided by 2125. So that's 2. So that's come down to 2. So 2 is equal to, this is crossed out, so we have this 1 plus r over 4. Again, make sure you put them inside parentheses. Your bunch, you already found this to be 60. So this multiplied each other. Okay, so it is looking much simpler. Now, if our variable is inside the parentheses, so if our variable was in the exponents, then we would take the logarithm of both sides to bring it down. But since it is a number that is in the exponents, we simplify it differently. We wouldn't need to take log, okay, because our focus is in the r. So, but we need to get rid of it. And what can get rid of this? Since it is a number, we can multiply it by its reciprocal. Reciprocal multiplied by a number gives us 1. So if that is 1, so reciprocal of 60 is 1 over 60. And whatever we do to one side, we do to the other. Right now, the exponent of 2 is 1. So if we multiply that by 1 over 60, like we did here, to make the equation balance, okay? So that will become 2 to the power 160 equals, this will cross out and become 1, so we are left with 1 plus r over 4. Yeah, so the exponent is gone on that side because our concentration is on the r. This one can have exponent, that's fine. Next, we can subtract 1 from both sides. So that would be 2 to the power 1 over 60 minus 1 equals r over 4. Okay? And since there are 2 terms, we want to put that inside parentheses too. And we can next multiply both sides by 4. So if we multiply both sides by 4, that will cross out and we get our r. Okay? So now, of course, we can plug this into our calculator. Okay, graphing calculator will do that for you. So we can do, okay, we can either start with the parentheses and after we finish, we multiply by 4, or you can try plugging everything in like this, see if the calculator will do it for you. Me, I will start with the parentheses first. So I will do 2 to the power, I'm going to put that 1 divided by 60. Okay, that's my parenthesis. So do that first. I will hit enter. Whatever I get, I just do minus 1. My answer minus 1. Hit enter, and then do times 4. My answer times 4. Okay, do it step by step just to make sure. Okay. So what do I have? Here they gave me my R is 0.046477. Keep going. Okay, so that's our R. Well, is that not the percent? What percent? Okay, the question says what percent. Percent of interest. So we are going to change this to percent. Write it in percent by multiplying this by 100. That will be moving this 2 places to the right. So that will give us 4.6 if we round up. So you can make 2 decimal places. So plus 1. So that will be 65%. So the rate will be 65%. All right.